everyone, Mike Amundsen here, and I want to talk to you about programming the future of APIs with composable services. Now, first of all, this is me. This is Mike Amundsen. This is how you find me on LinkedIn and Twitter and GitHub and YouTube. I would love to connect with you. I'd love to find out what you're working on, what's challenging for you in the web space, and what you can teach me. Most of the things that I talk about are things that I've learned from lots and lots of other people, and I would love to learn from you. So please keep in touch. Now, the material I'm going to talk about today, this notion of composable services for APIs, is from an upcoming book, RESTful Web API Patterns and Practices Cookbook. It's a long title, and unfortunately, it's a pretty long book as well. But it's a bunch of patterns and practices that I've collected over the years about how to connect services and orchestrate data in a way that makes sense. And this is one of the key patterns in the book, this notion of composing services. So I want to talk a little bit about the idea of why composable services are important and why they matter. What does a composable service really look like? I think we've been a little loose in understanding what this possibly could be and why it would be important. I want to talk about a really important principle of composability, and that is tasks and jobs. So a task is a single thing you might do, like compute the taxes or compute the total of a shopping cart. But a job is a series of tasks you might do, such as compute the total of a shopping cart, compute the taxes, send the shipping, handle the payment, and then send a notification. That would be a job. And it turns out that we need to treat tasks and jobs very differently if we're going to successfully build composable services on the web. And then I want to get right to it. I want to talk about a proposal for a RESTful job control language or a job control system. This is one I've used in various forms over the last 10 years or so. And I've decided to kind of come up with a generalized version of that we'll talk about. We won't get too deep into the weeds on it, but I want to show you what's possible and how you can start to think about this composability for the web when you're using HTTP. And then finally, we'll do a little bit of summary. We'll kind of wrap it all up and put it together. So if that sounds interesting, let's get started. So the very first thing is, why composable services? What does composability really mean, and why is it important? Gartner's VP, Daryl Plummer, has a great way to explain this. And he basically talks about composable business. That's one of the real keys. We talk a lot about composable business in the sense that we'd like to be able to put together a team to solve a problem. We'd like to put together a series of ideas to create a product. There's all sorts of composability we think about. And composability means that you're going to have an organization that's made up of interchangeable building blocks. Now, interchangeable building blocks doesn't mean generic. It doesn't mean building blocks that are bland. I mean, one of the key powers of composable organizations is they can apply their creativity and their energy at the right place at the right time. Composability has more to do with how the organization is put together and how the organization is established, not the contents of any individual block. And there are lots of reasons for that. Now, one of the things about composability is you've got a series of principles that you need to meet to create that organizational element. And one of the first ones is to get speed through discovery. You need to be able to find what you're looking for. Don't we have a team that knows how to do this? Don't we have somebody who's an expert in HTTP? Don't we have a component that can actually read files from an S3 bucket? These are the things that you need to do. You need to be able to find what's important. Second, you need to improve your agility, your ability to move quickly by using modularity. And we do this in source code all the time. We know that modularity is a key element in source code. Modularity is a key element in services and in organizations as well. The ability to take a team and move them to a different location to solve a particular problem. We used to call them fire teams when I was working. We had a team that would run around and solve a particular problem and then go and then solve another problem. Modularity is really important. Now, Gartner talks about this notion of leadership through orchestration, which I really love this idea. Leadership through orchestration means you lead by helping people work as a team. If you think of the real orchestra, the musical orchestra, there's a conductor in front, and she conducts everyone. Everyone has their own part, everyone does their own thing, but the conductor kind of brings it together and keeps everyone on pace. So leadership through orchestration is key, and that's the same in services. We're going to need to have an orchestration step, and that's what the job control language I talked about a few minutes ago will look like, and we'll see what that's like. And then finally, you need autonomy in order to have resilience. In other words, I need to have the ability to make some of my own decisions. I need to know what my scope of decision making is in order that I can move quickly. I don't have to wait on someone else to tell me what to do. You can't really expand or scale up if you're relying on one person to answer all the questions. So it's really important to have this autonomy built into your organization. And that's the same with services. Each client in a service interface needs to have some autonomy to be able to decide for itself what's possible and what's not. And that's the key to a composable business. So discovery, modularity, orchestration, and autonomy. These are all really important. So a composable business, the ability to do all of these things, needs composable services to animate it, to activate it. And that's what we're really talking about here. We need composable services to match this requirement. So what does composability really look like? I mean, it's not just an API that someone can use. It has to have more than that. It has to have all those things we talked about modularity and discovery and autonomy and orchestration. So here's some basic things to keep in mind when you're designing and building composable services. It's not enough for a service to be on the web or have a URL or have an endpoint or have an open API document. That's not enough. It's required, but it's not enough. You must design composability in. So the service, just like the organization, must be designed to be composable from the very beginning. And composability must be fully described at runtime. So this is really important. We're in an age right now where we're spending a lot of time describing services through definition documents like OpenAPI and Async API and GraphQL's schema definition language or protobuf for gRPC. That's design time description. I need runtime description as well. I need to describe on the fly exactly what arguments you need to pass, what URL to pass it to, what HTTP method to use, and what document format to use as well. That's part of this whole process of orchestration that we talked about earlier. And then finally, we need composable services to share state. So if I'm actually doing a series of steps like computing the shopping cart and the taxes and the shipping and the payment, I need to understand the data that is involved in this entire process. Now, one of the big challenges is how we share that data. I see too many organizations sharing that data with a database record or a database collection, which is not the right way to do it. What we need to do is share state in memory. We need to create a resource just like any other resource. And we'll talk about how to do that. So it's really important not to share data models. Otherwise, we don't get the composability we're looking for. So I talked about this. It's not enough to be on the web. Having a public URL is not enough. I need to be discoverable. I need to be able to find something. And in fact, what I need to be able to do is get a machine to be able to find it as well. And that means we need a registry of services that can be read at runtime. I and another person, Leonard Richardson, have proposed this idea of the Open Disco standard for a discoverable, interoperable service for continuous operation. This is a runtime service registry, or an RSR. You're going to need some way to know exactly what services are running and where they are running. Just like we use DNS today, we've forgotten that DNS is a critical part of every browser, every client application. It's kind of faded into the woodwork. We need the same thing, this naming service, but this discovery service for services themselves, not just for machines. So we must design in composability. For every single service that's composable, I need to not only be able to execute a task, but I need to be able to repeat that task safely. If I didn't get an answer back or somebody changed a value, I need to be able to repeat that service. And I also need to revert that service. I need to back it out. If I created a new shipping record, but the person canceled their order, I need to undo that shipping record. I need to roll that back. So that's designing in composability. So composable services are repeatable. We call that idempotent in HTTP. Idempotent, the same strength. It means that I can repeat it over and over again. Put, for example, in HTTP is idempotent, but post is not. Services also need to be reversible. I need to have a rollback or an undo for any critical case. Now, this can be tricky, but you can design services so that it's easy to undo what you previously did before. It means using more transactional services, the way event-driven services work, and it means remembering the thing you did just a little while ago. And we can do that through a couple of means. When we talk about the jobs control, we'll show you how to do that. But being repeatable and being reversible is critical to creating a well-designed composable service. Now, I also talked about the idea of describing at runtime. So we know about design time descriptions and we're using them very effectively, which is really, really good. But we now also have to have runtime descriptions for composable services. And we've had runtime descriptions for ways to compose services for quite a long time. They're called forms. HTML has had forms for 30 years. And we need the very same thing for every service. What URL do I use? What arguments do I pass? What method do I use? What format do I send? Whether it's JSON or XML or plain text or a form encoded, whatever the case may be. This is a critical element to composable services. So you're going to design this in to have a form that always describes how you can execute a particular action. So composable services support and emit forms in everything that they do. And then finally, we're talking about this notion of sharing state and not data models. This can be a bit tricky. It seems like it's a simple thing, but it can really be challenging. Composable services pass information back and forth, and those properties are passed back and forth via a resource, a document online. Here's where all of the variables are that I'm talking about for this particular job or this task, this checkout process or this onboarding customer process. And you collect all the data there. And for all those forms that services need to fill in, they can use this shared data document and read all the properties and write them into the forms. And when they get results back, they can write the results into the shared document. That shared property document, that shared state, is the key that glues all of the pieces together. And that's really critical. So if you're going to create composable services, you're going to read and write results to that shared state document. Composable services have a shared state resource, and we'll talk about how we can use that. So this is where we get the idea of self-describing. You may have heard this self-describing phrase in the REST treatise from 20 years ago. Composable services are truly self-describing. They have runtime descriptions for forms, and they pass data back and forth through a state model. That's self-description. So now we've talked about why composable services are important and what one looks like. Let's take a slight side trip. This is a slightly technical side trip that's really, really important. And that is that parallel tasks and sequential jobs is how we can get all of this to work. So think about that for a second. A web is a dangerous place. So there are lots of times when you might get confused about what happened or what's about to happen, or the network's unavailable, or somebody failed to supply an argument or something like that. So it's really important to understand how services work. A task does one thing and one thing well. A task is like that thing we talked about earlier that has an execute, repeatability, and a revert ability. So it's actually doing the real work. So I can do the work, I can repeat it any number of times, and then I can back it out if I need to. So a task is one particular thing. A job is a series of tasks put together, as we talked about earlier, such as checking out the shopping cart and making the payment and computing the taxes and then arranging the shipping and then sending a notification back to the customer. That is a job. Now, what happens is tasks inside a job have to be able to run in parallel, not in sequence. So think about that. I need to be able to run all these things basically at the same time. And this is exactly how most high-scale organizations work. When you think about what I just described, which is checking out, computing the last of the shopping cart, that's a sequential act. But then the idea of applying the taxes and scheduling the shipment and these other things, these can run in parallel. So I need to be able to run them in parallel and wait for all the results to come back. So a job is a set of parallel tasks. Now, this is really critical because if it turns out something happens that one of those tasks doesn't work, then that job fails. All of the other things get reverted, and then the job is reported back as canceled. So parallel tasks, sequential jobs is really, really important. And you can see the code example on the slide shows a little bit of how I can use, say, promises in JavaScript to actually implement that. Now, jobs also had this notion of being able to be continued or restarted. So, for example, I run a job and it gets halfway through and it gets canceled. Well, that's kind of a bummer. What I want to be able to do is actually restart the job and pick up where I left off, fix the problem. Maybe I was missing an argument or something, fix the problem and continue on from there. So that's a feature of a job. At the other end, I may also want to restart from the very beginning. If I had to cancel the job entirely, I want to run it again and know that I can safely complete all of the steps, maybe even repeat all of the steps with new values that I did last time. So we've got execute, repeat, and revert for a task. We've got continue and restart for a job. Now we're starting to build all of the principles, all of the features of a good job system, a good composable system. And this is exactly what we do in real life when we do it with organizations. Now we're just doing it with services. So tasks run in parallel, jobs run in sequence. And this helps us compose a very rich language without necessarily having to deal with Kubernetes or XML BMP or all these other products. We can design our own system to work the way we want it to work. So with all of this stuff laid out ahead of us, we need composability. Composability means to be designed in, and tasks and jobs are critical elements of this design. Let's talk about an actual proposal for a RESTful job control system. So a RESTful job control is a generic workflow protocol. It's a process that's for composable services on the web. Any service at all, even a service that you didn't create, or that you don't own, that you don't manage. As long as it follows the rules we talk about here, then you can enlist it into one of your own jobs. So what does that really look like? Now, this is a diagram of the flow of a job control language. It's a little bit hard to read. Don't worry too much about it. I'm going to give you a link later. But basically, it breaks down the basics of what a job control language can look like. And if you look at it, what you find out is this ability to create a list of jobs, find a particular job, and you can find right in the center of this diagram this thing called a job item, a job record, which has a whole bunch of actions. So along with remove and update, which are just managing the actual job record, you can see cancel, rerun, roll back, start, and there's also an update as well. So that's the heart of the system that we talked about earlier. So what I can do is I can compose a series of tasks that run inside a particular job, and I can run each of those jobs, or if I need to, back each of those jobs out step by step along the way. Now, once it's successful, I can actually call a different URL, and then that tells the system this job is complete. I keep a record throughout the process. I can cancel at any time. I even have this notion of timeouts. All of this adds up to a controllable job system, and it's based on some real simple elements. So this is the job record that we have kind of talked about earlier. It has a series of steps, its own ID and its own URL. Job IDs are like correlation IDs if you're doing correlation work with Kafka or other services or other distributed services. You have a series of URLs because everything is kind of driven by URLs on the web. And you'll notice one of the things on this list is a thing called the job max TTL, or time to live. That actually describes how long this job could possibly run. If it runs too long, it gets canceled right away. And that's a critical element in the story as well. Now, each job has one or more task records as well. Task records are the actual things to do, and they have the description and status and other things that we talked about earlier, including the start, the rollback and the rerun, the repeat that we talked about earlier as well. And there's also a timing for the job. So this in particular job or task, if it runs too long, then it's going to be canceled as well. Now, these sound a little fiddly, but each one of them is a really simple principle, and it's a principle that you can count on when you're designing your own services. There's some other stuff that I'm not going to get into right here, and this is primarily talking about some requirements that we've already discussed about what's rerunnable and what's repeatable and so on and so forth. But basically, job control language is a simple set of resources and URLs that share state and then collect parallel tasks and sequential tasks to get jobs done. So you can take a look at this. There's a URL in the collection, and you can look more at what job control really looks like. What we're really building here is the way organizations work every single day, but we're defining it. We're defining a runtime version of it, just like we talked about earlier. So job control actually lets you mix composable services at runtime. I don't even have to know that I'm enlisted in someone's job in order to compute the taxes or to figure out the total from a shopping cart or to figure out how to arrange shipping for a package that weighs 3 kilos. I can do all of those things independently. And that's what the web is really all about. So let's kind of go back and look at this a little bit again. Composable business needs composable services. Remember, we want that modularity, that autonomy, that discoverability, that orchestration in our organization. And we can do that in our services as well. So what do composable services look like? They're self-describing. They contain all of the details they need in order to run properly. That means that they describe all of the methods, all of the URLs, all of the arguments, even the source of data, the shared state of data that we're going to need in order to solve a particular problem. This is actually one of the biggest stumbling blocks for organizations, is creating truly composable services. Now, once we can create composable services that are self-describing, we can start to compose them. We can actually start to put them together. And we put them together as a series of tasks that live in a job. So we think about tasks and jobs as a way to describe the way we handle composability and services. And then we can take the way we describe tasks and jobs into a set of fixed principles. And that is really what the description of job control is all about. This is how I rerun something. This is how I cancel something. This is how I repeat something. This is how I restart something. It's a simple description that we just enable and then work step by step to complete. So the future of APIs is actually composable services. And the future of composable services is this RESTful job control language. That's what we need to start thinking about. What is composable? Composable is self-described, and self-description is the key to all of this. So I want to leave you with one more thing, a sort of a reminder about what the future is like and what the future can hold. And this is from Alan Kay. Alan Kay is credited with thinking of object-oriented programming, the Dynabook, which later becomes our laptop or our reader. Alan Kay was always a very creative person. And he was always good at predicting the future. And someone asked him why that is. And he actually used this quote: "The best way to predict the future is to invent it." And that's what I'm encouraging you to do today. Start to invent your own future of composable services. And that's by creating it yourself. So that's programming the future of APIs with composable services. And I hope this has given you some good ideas, and I hope to hear from you again sometime soon. Thanks.